Artificial intelligence is being promoted as the next revolution in electronics manufacturing. But what happens when the people evaluating it aren't traditional AI experts, aren't software vendors, and aren't selling anything? Today's conversation brings together engineers and professors who live at the intersection of education, reliability, and real-world manufacturing to separate meaningful progress from speculation. Welcome, or hopefully welcome back to Reliability Matters, a podcast dedicated to exploring the science, processes, and decisions that impact the reliability of electronic products. Each episode brings together engineers, researchers, and industry leaders to examine best practices, emerging technologies, and real-world lessons, always with a focus on data, physics, best practices, and long-term performance. Today's episode is a little different, and the setting couldn't be better. I'll be recording live from the Big Island of Hawaii at the SMTA Pan-Pacific Strategic Electronics Symposium, much better known as PanPac. At PanPac, academia meets industry in a way that's truly unique. Leading international universities join forces with CEOs, investors, senior engineers, and decision makers from around the world. This is where the brightest research collides with the most pressing industry challenges and sparks solutions that drive the future of electronics. I'm honored to be the conference chair, especially on this 30th anniversary of PanPac. This episode is all about AI in action, progress, pitfalls, and the future of electronics. Artificial intelligence is becoming a frequent topic in electronics manufacturing, from inspection and process optimization to predictive maintenance and reliability modeling. But rather than approaching this conversation from the standpoint of an AI evangelist or software developer, we're taking a different path. None of today's panelists claim to be AI experts. Instead, they are engineers and professors who sit at the intersection of education, engineering, and real-world manufacturing challenges. Their perspective is grounded in physics, data, reliability science, and decades of experience teaching the next generation of engineers, many of whom will be working alongside AI-driven tools, whether they choose to or not. Because all of our panelists come from academia, this conversation intentionally steps back from the hype and buzzwords associated with AI. We'll focus on how AI is actually being used, where it shows promise, where it introduces risk, and where critical gaps still exist, especially in high reliability electronics manufacturing. And because PanPac serves the electronics manufacturing community, we'll keep this discussion connected to the factory floor, workplace readiness, education, and long-term product reliability. We'll also touch on the broader societal questions, including how AI is shaping engineering education and professional intuition. So if you're looking for a grounded, thoughtful discussion on AI, one rooted in engineering reality rather than marketing claims, this episode is for you.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Panel, welcome to Hawaii. I'm so glad you're here.
Thanks for having us.
When my daughter was young, when she really thought something was cool, her phrase was, "Well, this doesn't suck." So I think we can say that about this venue here. Thanks for either agreeing or being voluntold to be here. I really appreciate it. Let's get started. I'll remind you to turn on the microphone if you haven't already. From an academic perspective, so this is like a professor question here. How do you define AI in action versus how AI is commonly portrayed in marketing and popular media? Separate fact from fiction here. Ron or Pradeep?
Maybe I can start. You go ahead, Pradeep.
So broadly speaking, I think presently there is a lot of hype around AI in terms of what it can do. We have seen a lot of excellence in certain pockets where AI has been applied. I think most notably the AI world kind of gained a lot of center stage attention when ChatGPT came forward, and we could see what it could do in terms of information that could be retrieved very quickly, inferences that could be made very quickly. In the engineering world, if one actually looks specifically in manufacturing, which is the topic of this particular panel, I think a lot of the excellence that we see in large language models has yet to be realized in the manufacturing world. And that's primarily because of the fact that a lot of the data that is required in order to be able to create those foundation models that provide the excellence in this particular space have yet to reach maturity. Data is an essential ingredient in AI, and AI models inherently are data hungry. And data is something that is very sparse in manufacturing space many times. You may have large pockets of very high amounts of data, but typically when the technology changes, a lot of the data becomes irrelevant. Materials change, the pace of technology maturation is very fast in manufacturing, and that's one of the challenges that we face in realizing the benefits of AI that have been seen in other spaces and making sure that they appear in manufacturing.
Yeah, it's interesting. I remember in earlier in my career, we would sell equipment to memory module manufacturers back when they were actually manufactured in the U.S. And I would go in to visit the customer, and on the way out, you had to go through metal detectors. Not the way in, on the way out, because memory was so expensive that a card, a little PCI card or a SIM card with 25 megabytes on it was, $300 or something. And memory's become so cheap and so ubiquitous. It's basically free. Ron, it's mentioned yesterday, it's like a penny a meg or something or less. That we've been able to collect data, and we collected everything. And now we actually have so much data. It's like a pyramid filled with sand, and we have to count the grains. It's like humans can't fathom all that data, but AI can. And I do think that the proliferation of memory and the rapid accumulation of data has given AI, although it has many purposes, a real purpose in that. I do think that's going to be one of the things we see. Ron?
Yeah, one of the things when like ChatGPT 3 came out, I noticed it would make mistakes when I asked it to do some homework problems just to see how it did. Now with ChatGPT 5, in many respects, I think it's breathtaking. I gave it my statistics exam, which I consider had some very difficult problems on it. It got 100. And one of the problems that I thought was the hardest, it answered in a way that was much more clever than the way I solved it. And so I think this is one of the challenges we have as professors is students overusing it. And they're not supposed to use it in the classes I teach on their homework or on take-home exams, but that isn't absurd. But to me, I think in the world of teaching the future engineers, it's an extremely powerful tool. It can help me to do a better job, but then balanced with the fact that if students overuse it, they'll never learn things themselves.
Yeah, I remember when calculators came out. I was in high school, and they were banned from high school. And, obviously calculators are welcome in high school. Now it's scientific calculators and all that. I think AI will follow the same thing. And I think they'll still learn, but the point where they get on the learning train will be further down the track because they'll have this big boost that, they still have to write prompts. They still have to know what they're asking. They still have to vet the information because AI is frequently wrong. So, I think it's scary in that, are we going to lose, logical thinking? Or are we just going to go farther because we have tools that do the heavy lifting for the logical thinking, and they allow us to, just start at a point further down the track? It'll be interesting to see.
So Ava's a graduate student at Dartmouth. Maybe we could ask her perspective on how it impacts her as a student.
Well, I can confirm I took that statistics exam. It was very difficult. And I think that we're facing a challenge being engineers in today's age where if you don't want your skills to be atrophied, you have to be very careful in the way that you use AI and the way that you prompt questions and look for answers. Because if you aren't doing the grunt work, if you aren't doing the hardworking challenge of overcoming failure and failing multiple times to get to a solution, you're not going to be able to be a good engineer and face those challenges in the real world.
Yeah, agreed. Hayden, any input on that?
Yeah, so it's definitely something that's much more prevalent at the lower levels of education. I would argue that it suffers in terms of a lack of data and a lack of, I guess, quote unquote experience when it comes to higher level things. So things that are more abstract will have a much more difficult time. But especially in high school, I know that every single one of my friends has used it at one point or another to varying levels of consistent use. But Ava's point on atrophy is a very, very important thing that I want to reiterate, because right now in high school, you're setting the foundations for college education. And a lot of my peers, and especially a lot of people my age, will be using it. So I think that's important to understand as you go along. The kids who are growing up with AI might seem a little bit different, but so kids of it.
Interesting. When electronics manufacturers talk about AI, and we hear this every day now, expectations are often very, very high. Where is AI truly delivering value today within the EMS world? And where is it just being oversold, in your opinions? Anyone who wants to start?
So some of the things that actually have been realized in other spaces are things such as object recognition. We see that in some of the engines that exist today. Object recognition has been used with some degree of success to be able to do defect identification, for example, in a high volume manufacturing environment by looking at defects that are optically detectable. For example, bent pins, misplaced parts, missing balls, circuit defects in a printed wiring board prior to assembly. Those are some of the examples, for example, that can be scaled from current models into the manufacturing environment and have found some success in many of the spaces. Another example would be preventive maintenance. So a lot of the maintenance in the present generation of machines is often done on a schedule basis. It's done based on fear of failure. I do not want to have my manufacturing line go down. And so therefore, I'm going to replace parts on a certain cadence. But generally, what could make a much larger impact is by perhaps doing condition-based maintenance, trying to assess the condition of the machine in real time and plan for these maintenance actions based on the current spot assessment of the machine or the manufacturing process. So those are some examples in which AI-based methods, more specifically machine learning type of methods, have made an impact in a limited manner.
I think if in the past, if someone was having a yield problem on their, say they have a small company, they have maybe 3 manufacturing lines, they had a yield problem, they'd probably call in a consultant. And today, the first thing I would think of is to get on Chat GPT and say, well, describing my process, my yield is only such and such a percent, first pass yield, I'd like to improve it. Could you suggest a plan to go on and essentially audit my line to try to improve it? And I haven't done this yet, but my experience with Chat GPT is it would do a pretty good job. And it's one of the things I think that you have to know enough to know if it does make mistakes, because it does. I don't think it's, at least in my experience, very common. But you have to know enough to know when it makes mistakes. But it can be such a time saver, and it can think of things that after you see it, you say, oh yeah, I should have thought of that. So I think it's something like, help me audit my line for it to improve productivity or first pass yield. I think it would do an amazing job.
On the subject of mistakes, I am prepping for this episode. I asked ChatGPT, tell me what mistakes you make. What's the downside of you? And I got a very surprisingly, I realize I'm talking to a machine, but I got a surprising answer. And I won't read the whole thing because it'll be a whole episode itself. Hallucinations was his first thing. Inaccurate, fabricated responses. These are its words. ChatGPT sometimes produces answers that sound plausible but are factually wrong or made up. And then it explains why. Like, that's a little scary when it tells you that. Now, maybe it's inaccurate. Maybe that's a hallucination and it's always accurate. But, it's the liar's liar dilemma. Stale or limited knowledge. I might confidently state something outdated unless a current web search is used. Well, okay, that's a little scary. And these are these words: lacks true understanding. I don't understand content the way humans do. I model patterns. I can mimic reasoning, not genuine comprehension. This leads to overly verbose explanations, misinterpreting nuanced queries, trouble with truly creative thinking. I'm not a source of truth or authority. I'm not legal, medical, financial, safety. And then my favorite was overconfidence. I have overconfidence in wrong answers. Even when uncertain, I might present an answer confidently instead of signaling uncertainty or requesting clarification. Hayden, you work behind the scenes. You write apps. You consult on AI at your young age. Any of these professions of wrongness sound real? Are you seeing that in your experience?
Well, you have to understand that the AI, when it responds to ChatGPT in this case, is getting that information from elsewhere. And so that information is most likely coming from people who've had that experience and are reporting it. So this is kind of, I think the right word is paradoxical, but when it's diagnosing problems about itself, it's not even doing that. It's taking the things that other people have diagnosed about it and then relaying that information to you. But to answer your question, yes, those are all valid concerns. I think that a couple of them are duplicates almost, like the very first thing about hallucinations and the last thing about overconfidence. So I think that serves as a good reminder of sorts that there's no real true understanding. So there could be something that it confidently states in the beginning and it reiterates the end, just in a different tone.
I also think that the real thing that these chatbots lack is context that only humans can really understand, where we live, the society that we're in. And so when you think about, like, instead of asking a consultant about your yield rates and how to fix those, if you ask a chatbot, it's lacking the experience and the understanding of what's actually going on and perhaps experience that it could apply to this real world problem.
From your perspective in manufacturing, in high reliability electronics, for example, what manufacturing problems remain, in your opinion, poorly suited for AI? Ron, you constantly give, when you talk about AI, you always like to say, AI will never unload a dishwasher, right? Fortunately, we're not unloading dishwashers in electronics manufacturing very often. But what do you think it really, we're just not going to get there?
Well, and I think one of the things that's probably oversold by people that they look at AI and see the amazing things, I would say, in the intellectual world it could do. And then people are thinking, they think of the movie The Matrix or Terminator. Any interaction with the physical world is really a challenge for an AI in a general way. The reason I say that is if you build some inspection system that's looking for defects on circuit boards, they can do relatively well. But to have a humanoid robot that can interact with the physical world in the way a human does is almost science fictional. And I believe is more than a generation away. We've seen some of these YouTube videos where you see a robot doing seemingly amazing things, and then you find out that most of them are someone behind the scenes, sort of like the Wizard of Oz with a virtual reality headset driving the robot to do it. I remember, and I'll close on this, there's a video where a robot folds a towel, and the creators are really proud of this. But anyone that's watched it says it's painful because it takes it 30 seconds when a human could do it in about 5. So I think that's where we're really overselling AI in its interacting with the physical world.
So I was going to add to that a little bit. From a manufacturing standpoint, I think one of the things that we often worry about is, for example, unknown unknowns, defects that creep in because of the fact that perhaps there is a previously unseen problem with the incoming material and incoming supplier. Changes have been made without visibility to the process itself. that produce downstream defects. So one of the problems that one gets into is that in the manufacturing space, a lot of the data, even though it might exist within a company, is proprietary and may not be available, for example, to an external engine, either because of privacy concerns or because of the fact that the data is on differing platforms that are not all in a format that talk to each other. So we often in the AI space talk about what's called federated data, to be able to get it into a common enough format where one can say, oh, I can use data from a pick and place machine made by Panasonic and a stencil printer made by someone else and an inspection system made by yet a third company. And the data actually is seamless. But today it's not. And so that also means that learning is not. It requires a human element. Spotting what's important requires a human element. I think those are challenges that need to be surmounted. The generic view of using large language models and tokenization and embedding, that may not scale as well, I think, into some of these other platforms because of the fact that the interrelationships are different. The technologies evolve. Not all data is in that common pool. While you and I can tell, because we work in that space, a machine may not be able to.
Interesting. Because this show's about reliability, I'm going to drag reliability into this conversation. Reliability engineering is grounded in physics and statistics and failure mechanisms. How well does AI integrate with physics of failure models rather than just replacing them? Does it integrate? Can it be part of it? Will it replace our current models? What's your prediction on that?
I'm going to go a little bit off that question. I'm going to use some of it, but I just want to say that when it comes to AI integration in a business, right, like you want to improve your efficiency or you want to save time, you want to give your staff a better experience working for you, then you need to understand that the way that you implement AI is just as important as if you were going for it. And what I mean by that is that unless you have an infinite amount of data, you're eventually going to get one screw up, and especially in high reliability manufacturing, that's not really something important. So, really prevalent model that I've seen so far, and one that's successful actually, it's that when you implement AI, what it's doing is it's helping you get to a point, but there's a human that's checking it at the end. Versus just the AI checks for you. So if you guys have ever seen in a checkout, there could be a camera that scans how much, I don't know, of some material that you have. Or another better example, let's say that you make books and you want to see how many books you have. If you get an AI to scan how many books you have, then you're going to have to trust that number, because to get a human to check that is just akin to doing it the regular way. You're not saving any time. But that's dangerous because you're relying 100% on the AI. So as opposed to if you're trying to, I'll start with Mark's about this yesterday, but as opposed to if you're trying to research something, if you're trying to optimize a process, if you're just using the AI to get from your starting point to the optimization point, then the human is checking at the end. So the risk is practically gone and you reap the benefits. So I encourage all of you when it comes to AI integration to consider how you're going to use it, because the way that you implement it is incredibly important. And you shouldn't just use it as a band-aid for every single ailment that you have.
I'm going to drag back in, kicking and screaming, reliability. And we'll use your book thing. Physics of failure, figuring out why books are failing, the content, the count, whatever, the distribution models. Will AI, do you think, crystal ball time, fundamentally change the way reliability is looked at with a whole new system, or will it integrate with best practices for reliability assurance today and add to it, kind of supercharge it? What's your prediction on that?
So I think what's going to happen, at least two very high-profile targets in the context of AI could be assessment of new systems, the reliability of new systems, which have previously never been made, in concert with computer-aided design tools, either MCAD tools, mechanical computer-aided design, or ECAD, electrical computer-aided design tools, so that one can assess the impact of material choices, process choices, design choices, as it might impact reliability. That's not something we can do today, but I feel that this is one of the areas in which AI can make a huge impact. And there are several pieces that exist today. My own team actually has been working on AI-based reliability methods development for over 20 years. We were one of the principal investigators on the IVHM program. This is Integrated Vehicle Health Monitoring Program, in which we looked at physics-based bases for development of AI-based methods. And back then, they were called by a bunch of different names: artificial neural networks, Siemens mapping, supervised learning, support vector machines, but they're all subsets of AI. Now, another area in which AI can really make a difference, and I think we kind of see a precursor to that on the automotive platform. Automotive platform has something called OBD. It's called onboard diagnostics. If something actually fails in your vehicle, there's a dashboard indicator light that comes on to say, hey, your oxygen sensor is bad, or your fuel tank door is open, or some other effect, for example, that may impact the normal operation of the vehicle. With AI and the emergence of many of these AI methods, what I feel would happen is that we would have real-time assessment of reliability during operation of an actual platform. So we are going to be able to prognosticate the future, to be able to say, well, you're using this vehicle and every user is different. And based on the assessment of your usage, I feel your vehicle is going to have a real problem within the next 5 days or the next 10 days. And that allows you to plan. And that's not something we can do today. What we can do today is we diagnose a failure at the time that the failure occurs. That's onboard diagnostics, present day, present time detection. And we are going to be able to foretell the future with some degree of certainty, or at least a probabilistic bound based on the current state of the system. I feel those two applications would really make a major impact on reliability.
I see a lot of head nodding here. No dissenters with that statement.
I think one of the things, at least from my perspective, that AI is good at helping you with information from the past. But if you're wanting to have some new model, some clever way of looking in the future, I don't think it's going to be that helpful, because I think it takes most of the information that's out there and can do great things to help you, like summarize it, whatever, do a workshop on it. But predicting future models, I think it would be less helpful.
We're going to ask both our professors this question, and then I want to get Eva's take on the same questions. Are universities keeping pace with the rapid adoption of AI in manufacturing, or is industry moving faster than academia? Let's start with Dr. Ram.
So I would say we're making tremendous efforts to use it. There are workshops at Dartmouth all the time on how to use AI. They're not really focused, I would say, on manufacturing. I think they're more focused on educating engineers. But it's something that literally, like once a week, we have an AI expert come in to talk about this. We have workshops on how to use AI with Excel and things like that. So I think we're doing a lot in helping to train the next generation of engineers to use AI more productive, but not necessarily focused just on manufacturing.
And Dr. Law, what's your take?
So I'd say that when first the generative pre-trained transformers came about, there was a lot of skepticism in terms of how AI could be integrated into a more conventional academic curriculum, and without undermining the learning process itself. How much is too much? If a student is really writing all the Python code using a generative engine, then are they really learning beyond providing the ability to create meaningful prompts? And is that learning scalable in the future to be able to do creative things? So remember, one of the advantages of AI is also one of its biggest downfalls. It learns of existing prior experiences. And if one doesn't have experiences in a particular space, that extrapolation sometimes becomes a little more probabilistic, perhaps, than we would like to have it happen. And so I think from an academic standpoint, I feel that AI does have a lot to provide to the academic learning process. I feel that the tools, techniques, and the process kits to be able to creatively use it in an academic setting such that we can enable the students to take full advantage of the AI tools and techniques without undermining the process of learning. That the dust on that quite hasn't settled yet, I feel. I think we are still in the process of assessing and trying to see what AI methods can do. How far is too far, and how would AI be best integrated into the learning process itself such that the learning is scalable, lifelong, and allow the student to be creative, yet without being overly reliant on a machine.
Okay, time for the fact check. Eva, what's your take on it?
I think it's interesting. Over the last 2 years, I see more and more professors saying, you can use AI on your assignments as long as you use a Gen AI statement. And I think we're still finding the balance between how much AI is too much AI. I think to this class that I took last spring with George Syvenko, it was an AI machine learning class, and we had in-class exams every Wednesday. And originally, for the first half of the class, we were allowed to use our computers, open notes, you could use ChatGPT, you can use whatever you want on these exams. And what the professor found is that a lot of the students were submitting like long pages of just pure ChatGPT response, and found that when students would come into office hours, they wouldn't be able to answer even the most basic questions that were on these exams. They could not answer anything. So the second half of the class, it was all just simple exams, like 2 questions, closed note. And students reported that after taking these more closed note exams, no ChatGPT, they actually learned something from the class. And I find that extremely interesting. So we're still finding the balance between how much ChatGPT is too much ChatGPT in a way.
Hayden, you're not in university yet. You're in high school. How does high school compare to what you're hearing at the university level?
Probably worse, if anything. I gotta say, most teachers nowadays in my school are pretty oblivious to AI as a whole. So what they'll do is they'll just stick a "don't use AI" sticker onto everything, be it tests, probably to tests, but be it on assignments, homework, projects, anything. And so what's kind of happened is it's like a veil. Pretty much every single student uses it. Every single student knows every other student uses it. So they're like, hey, why not? I'll use it as well. And the big problem that happens here is that now there's no transparency. So people are actually, everybody is submitting what an AI made and portraying it as their own. So there's probably an element of academic dishonesty there. There most likely is. But what I'm most concerned about is how this will extend to the university. And by extension, how this will affect careers they go into. Would they still be going down this path? And if not, then how would we go about it? So, it's definitively worse in high school just because, again, AI will have ChatGPT will have a lot easier time solving, intro to chemistry problems than super advanced abstract chemistry topics.
Hold on to the microphone because the next question is for you and Eva. From a student perspective, how does AI influence your learning and experimentation and problem solving compared to traditional engineering approaches or traditional solution approaches?
I think the number one thing is the speed at which you are able to prototype. I'm working on an engineering project right now, and one thing that we're exploring is the kind of material we should make our device out of. And instead of having to talk to a million different materials researchers and order a bunch of materials and test them ourselves, we're able to put into a chatbot, what materials do you think are ideal for this project? And we can get feedback on that quicker. So we're able to iterate quicker, prototype quicker, and therefore move our projects along a lot quicker in that respect. Do you experience the same thing?
Yeah, I mean, pretty similar thing in high school. Obviously, it's rather different from university. We're not prototyping anything. Rather, we're just going through class notes and such. The thing that I was thinking about for last 30 seconds now is that there's a completely different learning environment nowadays. And so obviously at a surface level, it seems super obvious. I mean, people ask ChatGPT questions or Gemini questions, but the whole method of sitting down and just trying to practice the problems of that stuff just been really excellent. But it can be predatory in the sense that if you're not actively trying and you just take the path of least resistance, then you end up with the AI just doing all the work for you. Yeah. And so a thing that students need, like good students are doing is they're actively separating themselves from the path of least resistance, which is very, very difficult. Mm-hmm. And that's the problem that is in academia so far, from my understanding. It's that a lot of students won't be able to separate themselves from that path of least resistance. And that's a problem that we're seeing over usage of AI.
If the audience has any questions for this panel, I'll ask you to just kind of shout out your question, and then either myself or one of the panelists will repeat the question so my audience at home can hear it. Any questions for our panel?
Terry has one.
How can we challenge AI to be accurate? We know it, and we do our AI search, and we get a lot of information, but we don't all get blinded. If you're challenging with the data and putting, here's my solution. I'm basically do what will get it with the P.
And someone repeat the question.
So I believe the question was along the lines of how can we prevent AI from hallucinating more? How can we improve the reliability significantly? And okay, here's the thing. When we think of AI, what we'll often think of is large language models. And some people in manufacturing might have experience with what's called an AOI, which stands for Automated Optical Inspection. The thing that we're trying to task, that the problem with our current usage, especially in the professional field, is that the scope that we're using AI for is incredibly vast. And what I mean by that is it's very, very difficult, and it's very challenging to ask it about various different niche questions in what's already a niche environment. So you need to understand that the scope is so vast that to reliably, and I say it's reliably as in 99.9999%, because the current architecture will never allow 100%. But you need to understand the truly vast scope. And if you want to get better results, you need to scale the scope down. And that's pretty much what vertical AI companies do. They focus on a very specific niche, get data sets for that, train the AI on that in order to get better results for that specific niche. And the reason that's not done for every single niche is just because there's so many. It'll take forever. And it'll cost so much. It's just not justified. Yeah. Just to summarize, scope, you need to scale your scope down and be reasonable. Quotation marks.
So Terry, I think you ask a very, very valid and valuable question. in the AI space, there is something which is called a stability plasticity dilemma. And so what that says is that stability has to do with the fact that, I'm going to give you an answer based on the vast amount of learning that I have. And I'm speaking as an AI engine at this point, right? So as an AI engine, I'm going to give you a stable answer based on the vast amount of learning that I have. But at the same time, I want to learn from the most recent information. So I want to be plastic enough to be able to conform to the latest information and provide you the most up-to-date answer at the same time. The problem and the challenge that relies in that whole process is that the AI engine can have bad information. But so as humans, we can tell, well, it all looks the same, but I can kind of tell that's just wrong. And AI engine cannot today. And so in a rush to be able to provide the most up-to-date answer, bad information might deviate the response tremendously and get you to a point where you don't want to be. And I feel that as we go along, that whole process of assessment of incoming information is going to get better. It's not quite as robust today as it needs to be. And I feel that's one of the reasons why we get bad responses and there are hallucinations and that there are extrapolations beyond where we want to be. But I think that question that you've asked is one of the more fundamental ones, and there has to be some true advancement for that to be surmounted.
So it kind of falls here and then read what you're seeing. But when we're looking at hybrid bonding, we know we have to take a different approach. And you can't just use AI. Okay. So you have to couple AI with machine learning. Okay, so as we're doing this, we have to look at different types of defects, teach the system what's good and bad, and that's going to take time and effort, okay, to learn. So once you identify what's good and bad, then you can use AOI and AI to help detect what you want. Because you got into this AI, it just go from, existing data, which is most likely irrelevant for what we're looking at for reliability, especially hybrid bonding, because it doesn't exist. So this is where, right now, what we're doing enhancement, we're at the University of Florida, the lead, and they're really putting this in their coupled with NVIDIA to make sense of this. Because now you have to teach the system good and bad, and that's going to take time and effort. Matter of fact, probably years to get an understanding of good and bad. And then you'd have to monitor what's good and bad to help teach it to look at what's good and bad from the future. And I think that's going to be an effective way to use AI for reliability testing. Because I think, Mike, that's what you're after, is how we use these techniques for reliability testing. And we know we have to think differently because look at, like, when you're dealing with 100 nanometer pitch, you can't just easily cross-section and look at the specialties fill and all that stuff. So this is where it gets into innovation, partnering with the right guys that really know this, like you would have NVIDIA. They're good, but then how can they solve our problems? So again, the way we're thinking about this machine learning coupled with AI.
Yeah. Clearly, next year I'm going to need a bigger table.
So, Chuck, let me just build up on what you just said. I think that is a very big area in which AI-based methods can make an impact, is development and faster ramp up of newer processes. So I think the common challenge that we often end up, just based on your hybrid bonding example, is many times as engineers, when processes are newer, they use different mechanisms, different underlying physics. Clearly, physics is different in hybrid bonding compared to what we use in soldering. And many times the process parameters that might be important might be experiential, and perhaps those are based on our experiences and they are the ones we capture. But there might be other parameters that might be a lot more insightful in terms of predicting what the manufacturing process throughput might be in hybrid bonding. The the strength of the bond, the coplanarity of the substrate itself, the amount of expansion that copper or the dielectric, surrounding dielectric might have. And that's where I feel AI-based methods can really impact and augment human learning from a standpoint of providing insights that may not be directly obvious by taking large data sets, decimating them to extract meaningful features that can be used to assess the propensity for defects. And that, I think, is not how AI is being used today, because we don't have the wealth of data to be able to do that. But that truly is an opportunity.
Yeah, follow that sound, right? If you bring up a really weird point, because what's happening now is, as we're getting involved in this machine learning AI pipeline, it's attracting other people that are interested. Like I mentioned, Fu and Kim at NIST. Okay, so they're starting to see this as a new opportunity to get involved with. So what's happening is we're attracting some really key brain power to help us rethink this, because it is a very new area, and it kind of address what you're saying. So it's kind of, Terry said, you said, I said that to you. So I think this is how this whole evolvement of AI for machine learning for reliability is going to work.
Let me see if I can sum this up. So, AI is powerful in information from the past. So a professor like me that wants to do a workshop on something, I'll put out an outline, and when I find what is really great about AI, is it will speed up the process for me, and it will think of things that I just forgot about. But I have to know enough to know when it's wrong. And for the type of workshop I'm talking about, it's not wrong that often. But one of the great good things for the future for young engineers is, as Chuck is saying, it is not in the realm of what needs to be done, new stuff. And so there's still a future for engineers and technicians and scientists in the new information and technology that we need to develop.
Okay, we're almost out of time, so I'm just going to ask two questions. One question for the professors and one question for the students. For the professors, what single piece, short answers here, what single piece of guidance would you give the electronic manufacturers looking to adopt AI responsibly?
I feel that there needs to be a concerted effort to create common data formats between different pieces of equipment that may exist, for example, in assembly and packaging, so that AI systems can then use some of the data to be able to create meaningful models. I think that's one of the biggest problems at the present time. A lot of the data is proprietary, it is hidden, it is either inadequately quantified, or if it's very well quantified, it's not available. It's in different data formats where it can't actually be meaningful, fully used to be able to create inferences.
I think, too, to understand that it's a tool, and certainly don't feel that your engineers are not doing their job if they're using it. It's a tool to help them be productive. But the other thing, too, I said this before, if you need to do something that interfaces with the real physical world, you're going to have to teach it how to do it, or have some sort of devices like optical inspection or something that you can integrate into your process and help the AI learn how to use it.
And for our students, in your opinion, is AI being overhyped, underhyped, or is it kind of like Goldilocks' perfect porridge? Is it just right? Where are we at?
AI is underhyped. The current AI we have is overhyped. AI as a concept is it is the future. And I will say that, and I will take liability if that doesn't work out. But AI is the future. It's just that what we have right now is not yet where I think most people would expect it to be. And I've preached this many times over, so I probably sound like a broken record by now. But we need to be realistic. We need to be down to earth about what the capabilities of it are, and to not just apply it as a a means to an end, like a panacea for all business ailments. So do learn about AI. Like for anybody who's listening or anybody who's here, do learn about AI. But learn about it so that you can also understand that, like, what it's not, understand its limitations, and just like, take a look at it from a more realistic standpoint. Don't just think, oh, it's hyperindulgent.
Wise perspective. Eva?
I completely agree with what Hayden's saying. And in my perspective, it's pretty overhyped. And I think that as it makes things easier, perhaps we get to do less calculations and focus on the more creative parts of our work. I ask, is it making us less present and less aware? I think of like the people in WALL-E. Are they happier because they have easier lives and they can perhaps do less hard work? Probably not. And in that respect, I think that it's overhyped.
Well, to my panel, we're about out of time. So for my panel, thank you for being here. And to my expanded panel behind me, thanks for being part of it. I have a feeling this conversation is going to continue at this event, at the lectern, and at Reliability Matters. Well, certainly, I think it's such a hot topic, and I think we are all aware in real time. We're watching history being made. Usually we don't realize the full impact of something until the next generation. I think I am certainly, for one, keenly aware that this is more than an evolution. This is really a revolution in its evolutionary format. It's snowball into a revolution, and I think it will change the world in many ways. And some of it will be for less good, and I think most will be for good. But like anything, it's in our hands as engineers, as scientists, as students, as professors. It's certainly in our hands. For my audience who wants to get more information, reach out to me. If you have a question for this panel, I know how to get a hold of them. So I won't put their email addresses out because I do want to protect them from getting spammed to death. But if you have any questions for the panel, feel free to reach out to me. If you're watching this on YouTube, leave a comment or email me, mike@reliabilitymatterspodcast.com. You all know how to find me. And I'll pass those questions on, and I will post the answers on the show notes for this episode, either on YouTube or on your favorite podcast app. So again, to my panel, thank you so much for your expertise and your wisdom and your outlook on how AI is impacting you. And to my audience sitting behind me, you can't see them, but thank you for being so involved. And I'll see you again in 2 weeks. And that's a wrap on another episode of Reliability Matters. Thanks for hanging out. Whether you listened on your favorite podcast app or watched on YouTube, I really appreciate you being here. A huge thank you to SMTA for generously allowing me to record this episode at PanPac in Hawaii. If you haven't already, hit that subscribe button so you don't miss future episodes. On YouTube, consider giving us a thumbs up and subscribe. Those 2 simple clicks really help us expand our reach. A huge thanks to PCB Chat from the Printed Circuit Engineering Association at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Got a question or an idea for a future episode? I'd love to hear from you. Just shoot me an email at mike@reliabilitymatterspodcast.com. And if you want to learn more about the podcast, head over to reliabilitymatterspodcast.com. Thanks again for being here. Until next time, keep learning, keep doing it right, and remember, reliability matters. I'll see you again soon. Mahalo.
Thanks for listening to the Reliability Matters podcast. Join us on the 2nd and 4th Tuesday of each month for new episodes of Reliability Matters.